Now we're going to look at compositions of functions using tables. Here I have a table of values, and along the top row I have some specific x values, and along the left column I have three different functions: f of x, g of x, and h of x. I'm going to use this table to find the values I need for different expressions and eventually some composition functions. First, I'm going to find h of 0, then g of negative 3. I will substitute these into the expression and then just do the arithmetic. So for h of 0, I will find my x value of 0 along the top row. I'll move down the column to the h of x function and find that h of 0 is 2. And I make the substitution. In place of h of 0, I've placed a 2. Now for g of negative 3, I locate the x value of negative 3 along the top row. I move down the column to the g function, and I see that g of negative 3 is negative 2. And then I make that substitution as well. Then I simply follow order of operations to find negative 3 times 2 times negative 2, and I get positive 12. Let's do another example. In this expression, I need to find g of negative 1 and f of negative 2 by using the table. So I locate negative 1 along the top row. I move down the column until I get to g of x, and I find that g of negative 1 is 7. I find negative 2, and then the f of x row shows me that f of negative 2 is 3. Substituting those values into the expression gives me 14/3. How about pause the video and see if you can find h of negative 2 plus 3 times g of negative 1. Did you find that h of negative 2 is negative 1 and g of negative 1 is 7? Once you substitute those values into the expression, you can simply perform the arithmetic. Negative 1 plus 3 times 7 is 20. I want to remind you what this notation indicates. H times f of 2. It simply means you're going to find h of 2 and f of 2 and multiply the quantities together. So we're looking in the same column where x is 2, and we find that h of 2 is 0 and f of 2 is 3. And 0 times 3 is 0. Now we're going to look at a composite function or composition of functions. H of f of 2. Here we have a function embedded inside another function. We're going to start from the inside and work our way out. So first, we must find f of 2. According to the table, f of 2 is 3. So I make the substitution. In place of f of 2, I've placed a 3. Now I'm ready to find h of 3. According to the table, h of 3 is negative 1. How about this one? Let's do another. Once again, we start in the middle. We're going to find f of negative 3. Do you see f of negative 3 in the table? Right there it is, 0. So we substitute 0 in place of f of negative 3, and now we find g of 0. And g of 0 is negative 2. Pause this video and see if you can find h of g of negative 2. Did you find that g of negative 2 is 1? And then h of 1 is negative 3? I sure hope so. How about this one? Pause the video and find g of f of 3. Did you get that f of 3 is 2? And then when you substitute 2 in place of f of 3, you next need to find g of 2. Did you get 5? Well, you could keep pausing and trying these. Find f of h of 1. H of 1 is negative 3. Upon substitution, you will now find f of negative 3, which is 0. You gotta admit it's kind of fun, huh? Oh, here we go. What about h of g of f of 2? It looks complicated, but we're just going to take it one step at a time. Start in the middle and find f of 2. You find that f of 2 is 3, and so you replace f of 2 with the number 3. Again, we're working our way from the inside out. So next, we find g of 3. And g of 3 is negative 3. Last, we find h of negative 3, which is 1/2. Let's do another one like that. Here we have g of h of f of negative 1. Again, just take it one step at a time and find f of negative 1 first. F of negative 1 is 2. So we replace f of negative 1 with 2. Again, working our way from the inside out, find h of 2. H of 2 is 0. So lastly, we find g of 0. And the answer is negative 2. If you think you're ready, pause the video and find g of f of g of negative 3. Let's work our way from the inside out and find g of negative 3 first. We find that g of negative 3 is negative 2. So next, we find f of negative 2, which is 3. And last, we find g of 3, which is negative 3. All right, let's kick it up a notch. Question M says, if k of x is equal to 2x plus 10, then for what values of x is k of x equal to f of g of h of negative 1? Notice that k of x is not represented in this table, so we'll simply need to realize that k of x is 2x plus 10. We will use the table to find f of g of h of negative 1 and set the quantity equal to k of x and solve. So first, let's find f of g of h of negative 1. Always working from the inside out, we find that h of negative 1 is 1, and we substitute that quantity in. Now we find g of 1 is 0, and we make that substitution as well. And finally, f of 0 is negative 4. So we found that f of g of h of negative 1 is negative 4. So now we're ready to set k of x equal to negative 4. Remember that k of x is 2x plus 10. So we simply set 2x plus 10 equal to negative 4 and solve this very simple algebraic equation. Subtracting 10 from each side gives us 2x equals negative 14, and dividing by 2 equals negative 7. So for what values of x is k of x equal to f of g of h of negative 1? 7, or negative 7, I should say. Okay, back to the table and question n. If p of x is equal to the absolute value of 2x minus 3, then for what values of x is p of x equal to f of g of negative 2? So similar to the previous problem, we need the table to find f of g of negative 2. Working our way inside out, we first find that g of negative 2 is 1, and f of 1 is 4. So f of g of negative 2 is 4, and we want to find out where p of x is equal to 4. But remember that p of x is the absolute value of 2x minus 3, so we simply want to know where that is equal to 4. Remember what absolute value means. It means the distance from 0 on a number line. So this sentence, the absolute value of 2x minus 3 equals 4, says that the number 2x minus 3 is 4 units away from 0 on the number line. There are two numbers on the number line that are 4 units away from 0, 4 and negative 4. So we set 2x minus 3 equal to 4 and negative 4 and solve to get our two solutions of negative 0.5 and positive 3.5. In set notation, I just put them in order from least to greatest. And that's the end.